I work in the navigation and mission design branch. Really, we answer two basic questions about trajectory, design, and navigation, which is where do you want your spacecraft to go and how do we track it when it's there?
We support numerous mission types, everything from low Earth orbits to lunar missions to cislunar missions, which are in between Earth and Moon, to planetary and even heliocentric orbits.
A lot of times we get this opportunity to really see the mission from the very beginnings of the initial idea that someone has to explore some new science, all the way out to implementation, all the way out to the operations room where we're standing here to be able to actually implement that mission and be able to really achieve that science and discover new things.
Flight dynamics is really exciting because every mission and every day is different. I work with low Earth science missions, and that generally means missions that are in the regime from a couple hundred kilometers to about 1,000 kilometers. Aqua Aura Terra, Landsat 7 and Landsat 8 fly in a constellation, so we have to be really careful about their interactions with each other and where they are, make sure that they're not going to get too close to each other, and it's really important to get that Earth science data for climate research and for current weather predictions.
It's an exciting time supporting lunar science now with a renewed focus on the Moon. We have low-thrust CubeSat missions in development, and we've been flying the Lunar Reconnaissance Orbiter since 2009. It has returned a treasure trove of data in the past 10 years on where the water ice is at the lunar South Pole, as well as to map out the entire Moon, finding where the hazards are for future robotic and human landing locations on the surface.
We've flown missions to the Moon. Now we've flown missions out to beyond a million kilometers from Earth to the Sun-Earth libration points. Now we're going out to asteroids, we're going to Mars, and we look for even further beyond that.
When we get farther away from Earth, we can't rely on GPS anymore, so we use different techniques such as optical navigation, where we image celestial bodies, such as on the OSIRIS-REx mission, where we use a camera to image the asteroid Bennu to navigate the satellite.
We launched in September of 2016 and arrived at the asteroid in December of 2018. And since then, we've been performing detailed characterization in a series of hyperbolic trajectories and orbits to allow us to learn as much as we can about the environment of Bennu. From a navigation perspective, the OSIRIS-REx mission is one of the most challenging ever executed, mainly because of Bennu's size. It's only about 500 meters in diameter, with a gravitational attraction of 16 orders of magnitude less than that of Earth. Because of this small gravitational forces, we have to take into account a lot of the perturbing forces that are typically ignored or only considered in most navigation applications. Our team has been pushing the boundaries for small body and interplanetary navigation and has set us up for a successful mission to date and in preparations for our touch and go sample collection in 2020.
I was the flight dynamics lead for the Transiting Exoplanet Survey Satellite, which is a telescope looking for exoplanets, specifically exoplanets sort of in the Goldilocks zone that could harbor life. The Kepler mission flew for 10 years and found just over 2,000 exoplanets. TESS, since it's launched a little over a year ago, has found over 1,000 already. So that is very exciting, and it makes us look forward to the future.
The James Webb Space Telescope is a successor to the Hubble Space Telescope, and it's going to be designed to explore the birthplace of stars, planets, and galaxies. What it's doing to get there, to do that science, is a trajectory going to the balancing the Sun, Earth, and Moon in what is called a Lagrange point. It's called the second Lagrange point in particular, and that's beyond the Sun-Earth line. And hopefully over there, it'll be able to keep the Sun behind its back while it explores the universe.
My name is Sam Schreiber, and I'm the Deputy Operations Director for the Goddard Flight Dynamics Facility, or as we call it, the FDF. The Flight Dynamics Facility supports science missions, like we fly tests here. We're going to fly the James Webb Space Telescope. We've also flown the Hubble Space Telescope here. But we also support human missions, such as the space station, visiting vehicles to the space station. We'll also be supporting missions going to the Moon and hopefully beyond.
It's not only the mission support. The other part of the excitement that we have is also working with outreach programs. We have a lot of students that we work with in the NASA Student Technology Research Fellowships. We do a lot of internships. We have dozens of students come in over the summertime to work with us on different applications. And all those innovations are really exciting to see, that we get the latest and greatest information that are being developed by the universities that gets put back into our software and hardware.
We are really lucky. We're all basically working our dream jobs. Most of us grew up dreaming about space, and yeah, we're just really lucky to be able to work in jobs that we love.